Watch him say go.
What? What?
Huh?
We're ready. All right. Boo-boo-boo. Boo-boo-boo-boo-boo. It's a catchy tune.
That's music stuff.
Okay. Hey. Hello, everyone, and welcome to our Sunday night offering of Astronomy Outreach for May the 22nd, the Sunday Night Astronomy Show.
Yay!
Yay! That's better. That's better. We're learning. 131 shows. 131 shows tonight. Episode 131. Hey!
Wow.
Wow.
Who's
Great.
counting?
Yeah, I did today. I counted today. Anyway, my name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay, and I'm an amateur astronomer and a member of the Royal Astronomical Society of Canada. And first of all, I'd like to welcome back my two regular co-hosts, fellow RAS member Mr. Paul Owen from the Moon Shadow Observatory in beautiful Hampton, NB. Welcome, Paul. Evening.
Evening.
Hey, and I'd like to welcome back our other regular co-host and fellow RAS member, Mr. Mike Powell from the PFO Observatory here in St. John, New Brunswick. Welcome, Mike.
I'm just a roadie.
There you go. That's okay. A roadie with a job to do tonight. Okay.
Oh, yes.
Okay, so on tonight's episode, those who practice astrophotography regularly have to deal with removing objects like planes and satellites from their images. It's a relatively easy process and more of an annoyance for, well, it is for you guys. Not easy for me, not at all. I give them to these guys. But there is a real threat overhead, one that cannot only soon affect human space flight, but also pose a risk to many of the space satellites that we have come to rely on. Like when you want to go get your banking, your banking money, that kind of stuff, or your Netflix. The U.S. Department of Defense's Global Space Surveillance Network currently tracks more than 27,000 pieces of orbital debris or space junk. Now, there are about 23,000 pieces of debris larger than a softball orbiting the Earth. They travel at speeds of up to 8 kilometers per second, fast enough for a relatively small piece of orbital debris to damage a satellite or a spacecraft, or even the ISS. There are also 500,000 pieces of debris the size of a marble or larger, and approximately 100 million pieces of debris about 1 millimeter or larger. So tonight we're going to take a closer look at some of the danger provided by this orbital space junk and what must happen before there is a major catastrophe. Also tonight, Vinyl Bud returns with another favorite binocular target to enjoy, the Seven Sisters of the Pole, as I'm told. And Mike will return with another Mike Guyver DIY idea as well. This time it's how to keep dust off your optical train after you have removed your dust cap. Awesome. Okay. Look forward to that. Paul will be here with another interesting Rosanna's Fun Facts episode as well, and he'll provide us with his newest astrophotography tip of the week, where he'll be discussing white light filters. Cool. Okay, I'll introduce a number.
Ding.
Ding.
Next slide.
TV dinner's ready.
I'll introduce a number of celestial events to watch for in our What's Up This Week segment, and we'll have all of your wonderful photo submissions to share as well. So remember now, this is a family-friendly, interactive live broadcast. So for those of you joining us from my YouTube channel or Facebook page, We are happy to try to answer all of your astronomy questions in real time as well. And of course, we'd like to welcome back all of those who have been joining us through the Rogers TV network. Welcome back.
Hey.
So let's get started then, I guess, guys, with tonight's program and a discussion on space junk. Welcome everybody on Facebook and YouTube. Thanks for joining us. Okay, who'd like to carry it off?
Well, I can just give people a rough estimate of what space junk is actually out there when we talk about space junk. I'll share my screen here for a sec. Share. This here website, what's it called? Astrica, something.ca. Anyway, if you look closely, I'm zoomed in quite a bit. You'll see New Brunswick, Nova Scotia, and you'll see a bunch of dots on the screen. Now, the orange ones, like you see right here and right here and right here, these are active working satellites. If you see something that's baby blue, these are inactive satellites, and you see they're moving. This is in real time. If it's purple, it's a rocket body, which I don't see any rocket bodies in our field of view there. But if it's gray, like you see here, here, that is debris. And then there's another category, which is basically highlighted, I don't know what you call it, fluorescent pink. And that is uncategorized debris. Now watch what happens when I zoom out when we're thinking about space debris and what's floating around up there in above our atmosphere. I start backing off and you start seeing more. There's a Starlink chain right there going on that side. But you see the dots, and every one of those is a piece of debris or something out in space. And look at the uncategorized, the stuff that's starting to show up as I zoom out even more and even more and even more. And you wonder, how are we going to get to the moon by dodging all of this stuff again? Because the rocket's got to go through all of this. I haven't even, got halfway to the moon yet. But look at the debris and space junk that they're tracking live going around the Earth. You get to a point now you can't even see the Earth. It's all dots. That gives you an idea of how much space junk is actually out there. And this is just what they're tracking live. You can see the clock here in the corner. And as you zoom in and go through all of this stuff, but I mean, that is a lot of space debris. And you wonder why every once in a while they have to shift the ISS or, they talk about the catastrophic failure of a satellite when one eventually is going to hit another one. And it's happened a couple of times. The Chinese fired a rocket up and exploded a satellite just to prove that they could do it. That added another 2,500 pieces of space junk. Then a Russian satellite ran into an American Iridium satellite. That added another 3,500 pieces of space junk. You don't think with this many satellites up there and them all floating around, something's inevitably going to hit something else and cause that much more. And it's not getting less. It's only increasing. I mean, we had that show, about 2 months ago that talked about how many launches we had in 1 month?
Yeah.
Every single one of those launches leaves a piece of debris up there of some sort, whether it be a flake of paint, a nut, a bolt, right? A piece of wire, something floating around up there. So that's just to give you an idea why you can understand if you're trying to even do astrophotography, why something's going across in your field of view before you finish your shots. I just wanted to show that and share it. I mean, it's crazy the amount of junk that's up there. So
Wow.
It is. It is nuts for sure. There was one. Yeah, there's one. I mentioned to the guys before we went on the air there. There was a mission by Russia, I guess the Soviet Union at the time, that had sent a lander. Well, had tried to send a lander to Venus, and it didn't make it. They did land a few of them, the Venera ones, but one of the ones that they sent that didn't make it ended up in Earth orbit. Now the problem with that is that because it was going to Venus, it was going through an area of a lot thicker atmosphere, so the drag or the resistance on the spacecraft would have been a whole lot more. There would have been a lot more friction, a lot more heat. So it would have survived all the way to the planet Venus. But since it didn't make it that far, it's in orbit around Earth. And the problem with it now is that when it does come back through the atmosphere, it won't burn up completely because it was designed to land on Venus. So that's just one example of the products that are up there. And there are a lot of spacecraft or a lot of these satellites that they're building now that have materials like titanium and stuff that will not burn up in the atmosphere. So parts of the satellites will still make it all the way back to Earth.
And larger stuff, it doesn't necessarily all burn up. Like there's larger pieces up there that come down. There's actually a gallery of fallen space junk that you can go to, and it shows space junk that landed in people's backyards.
Right.
And stuff like that. It's called When Space Junk Falls to Earth is the name of the website. And it's crazy the amount of stuff. Like helmets. They've actually, unfortunately, had some space helmets land in people's backyards in Houston and stuff from Challenger and things like that.
Yeah.
You know, this stuff, it doesn't all burn up.
Yeah. I mean,
necessarily.
Something like that, the shuttle would have had a lot of materials I would expect on it that wouldn't have burned up.
You know, there's a lot of carbon fiber tanks and things like that that don't burn up because of the way they're built.
Yeah.
You know, oxygen tanks or fuel tanks and things like that. They come on down and hit the ground if they're not over thank God they haven't been overpopulated areas. I don't think there's anything on record where anybody's been hit by one yet, but I think it's inevitable. The key word is yet.
Yeah, that's right.
What was the name of that site you were just on, Mike? Everybody's asking about that.
Hold on here. The tracking one?
The one you just showed all the dots on it.
Yeah. Wonder if I can paste it here.
I was going to say, with all those dots, and everybody should just remain calm. Could that be called .com?
.com,
Oh,
yes.
Oh, boy.
Spacejunk.com?
Oh, boy. I might have to get one of you guys to log on. Are you one of you guys watching YouTube or no?
Yeah, YouTube.
What's that?
No.
No?
I can.
Maybe I'll get one of you guys to watch it because it's locked up on my end. I'm not able to change anything.
Just
so
see if I can pull it out here.
Yeah, just
I posted that website.
Awesome. Thanks, Mike.
People can see it. There's another one called Space Junk or spacegarbage.com or something, and the website's down right now. I tried to get into it earlier, but it's not there. Spacedebris.com or something like that. But,
well, there's something else too. There's we talked about before we went on the air about a graveyard orbit for satellites. So there is an orbit about 22,400 miles above the Earth. I guess around 30,000 kilometers or so, where they do send spacecraft or satellites when they're at the end of their mission, when they can, if they have enough. If they have enough fuel left on them, they'll send them up to this higher orbit, and they're way out past the GPS satellites and stuff. So they're a long way out.
There's even a car out there.
Even a car out there, yeah, that's right.
Tesla's got his car out there.
Yeah, sure enough.
Elon Musk.
But there are so many pieces that don't make it up to the higher Earth orbit as well. So I could share that video, guys, if you want.
Yeah, it's kind of a cool video.
Okay, hang on a sec. I'll get this.
Apparently, we're being watched on Facebook and YouTube, and there's no issue.
Okay.
Yeah, no, I'm on YouTube now, and I can see it just fine.
Yeah, I'm seeing the show okay, but the last comment that I see was from Brad, and I went to put in a comment myself, and my screen locked up. So if you see comments after Brad Perry's comments, and if you just keep an eye on them and comment if necessary, that'd be great.
I don't see any comment.
Okay.
Oh yeah, no, there it is. Yeah, Brad Perry.
Okay, that's the last one I see. Anyway, okay, I'll share my screen then. And I know you guys won't be able to hear the sound, but you'll be able to see it at least. For some reason, Google Meets doesn't allow you to play the sound. So I'll get this one up first of all. A little bit here, about a 3-minute video or so from ESA, which is the European Space Agency, and what they're planning on doing with space junk.
For 60 years, we have launched satellites, spacecraft, and astronauts into space. As a result, the Earth is surrounded by a cloud of debris. There are more than 18,000 objects being tracked from the ground, at least 750,000 fragments of around €1 in size, and millions of pieces that are smaller. Only 1,100 are functional spacecraft. and at typical impact speeds of 40,000 kilometers per hour, all this material could do serious damage.
It is not comparable to a gunshot. The energy contained in a 1 centimeter particle hitting a satellite at that velocity roughly corresponds to an exploding grenade. So the consequences of such a hit mean a satellite failure, for larger objects, even satellite destruction and fragment generation, which again then has environmental consequences.
We rarely get to see the effects of space debris, but in 1993, during the first Hubble servicing mission, a solar array was removed from the Space Telescope. Back on Earth, the panel was found to be peppered with damage. What space debris experts fear most is a chain reaction, where objects break apart in collisions and fragments go on to smash into other objects, creating more debris.
These collisions generate more fragments, and these fragments are candidates for new collisions to come. So follow-on collisions, if you like. And that the largest fear that we have is that we enter in some sort of cascading effect, where one collision triggers the next one. And this is not anything that will happen within a microsecond like in the movie Gravity, but this is something that will set in slowly, hardly noticeable, but unstoppable. Over decades, the frequency of collisions might increase without human influence. That is a scenario that might render some regions in space unusable for spaceflight, and that will be a disaster for spaceflight.
Here at ESOC, ESA's team tracks space surveillance data and plans manoeuvres to keep the agency's operational satellites out of harm's way. ESA also ensures that when its spacecraft come to the end of their operational lives, they can be taken out of orbit to burn up in the atmosphere, plunge safely into the ocean, or move to so-called graveyard orbits, safe from collisions. Concepts are also being developed for missions to capture and remove objects from orbit, perhaps using nets or sails. The top priority, however, is to avoid creating a new generation of space debris.
Use of services from space is in everybody's interest. Mitigating the problem, space debris, should be in everybody's interest as well, because we have generated a global problem that can only be solved on a global scale. It needs a global response.
With hundreds of new satellites due for launch in the coming years, ESA is working with its international partners to ensure this orbital pollution doesn't get any worse.
Okay, so there's a little bit of a look at what the problems are.
Crazy, isn't it?
Yeah. You know what they're planning on. I got another video here I can show right after this. Maybe I'll show that one next. Just a quick view of what they're planning on. And there is a contract. ESA has already put a contract out right now for a company to remove a satellite from orbit to give it a try. So here's a second video. And that's their idea.
And I was mistaken. There was a lady in Tulsa, Oklahoma that was hit by a piece of space debris and lived to tell about it.
Pardon me, guys. Really? Yeah.
Yeah. Her name was Lottie Williams. Was strolling through the park in Tulsa, Oklahoma, when she saw a flash of light resembling a meteor. She was struck by a piece of metal, apparently from a disintegrating rocket.
Wow.
The only person believed to have ever been hit by a piece of space junk.
Wow.
So it has happened.
She goes by the name Lucky?
Lucky Ludi.
She does.
Great. Well, I got some interesting stuff to tell you that's up there, which is kind of neat. This was put out by National Geographic Kids, which is kind of cool. So if you want to go on the site, you can. I'm not going to bother sharing the site. I'll just tell you a couple of the things that are on it. One thing that's up there, which I guess we've never thought about, but there are some dead animals up there. And so before humans went into space, it was not uncommon for animals to be sent. So apparently what they, of course, back in the, I think it was the 60s and 70s, they didn't know what it was going to be like out there. So they just decided to send animals out as they would, just to make sure that it was safe for humans to travel out there. And I guess there were some 30 some primates that were sent out there, all with the name Albert. And unfortunately, not all of them made back. So there are a couple of Alberts and maybe some dogs that are floating around up there as part of our space junk. Another thing that's up there, believe it or not, for you Star Trek fans out there, portion of Gene Roddenberry's ashes are actually sent up and they're in space. And I think that happened back in 91, I think it was, or somewhere around there. But when his wife finally passes, then her ashes and the remainder of his will be sent up into space as well. So there is some very high-end space junk right there for all of us Trekkie fans. That's kind of cool. That's out there. Another thing that's out there, which I found kind of cool, is there's some Lego. How many of us stepped on Lego? And,
Wow.
you know, and to the moon. Well, anyway, it's not that far off the mark. So in 2011, 3 specifically crafted Lego figurines of the Roman god Jupiter, his wife Juno, and father of science Galileo hitched a lift to Jupiter on NASA's June's mission. And the figurines are set to arrive on July 2016. Anyway, so Lego, there you go.
Crazy.
Out into space for some more junk. I'll add some more as we get on there, but I just want to put a few of those in there for now. Some things we wouldn't think of other than metal pieces and parts, and
Exactly.
of which none of these were.
Yeah. Awesome. I'll go with one other quick video if I can. Just going to talk about the idea that the ISS, NASA is doing actually right now with the ISS, and it's called the Space Debris Sensor, and they're going to be installing it on the ISS. May have already been installed. There, that's that. So orbital debris poses a risk to all spacecraft in Earth orbit. So the International Space Station is getting a new debris impact sensor to provide information on the micrometeoroid orbital debris environment in low Earth orbit. The space debris sensor launching on the next SpaceX Dragon cargo vehicle will monitor impacts caused by small-scale orbital debris for a period of over 2 to 3 years. That data will improve station's safety by generating a more accurate estimate of the amount of small-scale debris that cannot be tracked from the ground and helping define better spacecraft shielding requirements. So there we go.
Wow.
So they are doing something. I mean, ESA seems to have a better handle on it as far as bringing their spacecraft back down, but that might not be either. I mean, we're looking at decades really of missions that have been around Earth orbit and farther out, of course, with all these like the second stage of these rockets and stuff. And we've got to make a clear effort here to clean this part up, and we also have to be sure that when we put another satellite into orbit that we have a plan to bring it back down again. I think that's all part of the plan. You can see now that they're putting up all these CubeSats. That's the newest thing, right? They're only about the size of maybe a small television. And was it India? I think it was India that just launched 100 of them at once. And they only have a short life, like maybe a couple of years of life, and then they're defunct and they just sit there and fall around the Earth like everything else. So you've got 100 of these being launched every few weeks, and they're very economical for companies to put up because they're very cheap to build. So if they're just looking for one particular type of information, they can get it from the small CubeSat satellite. So again, they're only like 2 feet long, maybe a foot by foot, and they're up there 100 at a time. So we could be putting thousands of these up, right? Mike, you mentioned that, was it 12? There's 1,200. There's how many satellites that were defunct up there right now? Did you say 20-some thousand? No, 12,000.
Yeah, 12,000.
12,000 defunct satellites up in orbit right now, and there are only 1,200 apparently that are actually working in orbit right now. So that's the numbers that we're talking about. 10 times as many up there that are defunct than the ones that. And all it takes is 2 of them to collide together.
Yeah.
And you've got thousands or tens of thousands of pieces now that are floating around. And I mean, everything's traveling at 8 kilometers per second. There's no doubt about that. But not everything is traveling in the same orbit. We're going around the pole this way and around this way, and so that's where the collisions can come from, right? So.
And out in the middle of the Pacific, isn't there a satellite graveyard area that they call it now? So if they can bring them back. If they don't burn up, then of course they land in the ocean in that area where it's least populated, of course. But that doesn't stop, the pollution of going in there, all these metal parts and leftover fuel, and God only knows what other stuff.
That's right. So
going back into the ocean. Way back in the 60s, there was a thought of grabbing satellites and flying them towards the sun.
Mm-hmm.
Right? Dispose of them that way.
There was a satellite I was reading about that they had to actually put it in orbit around the sun now. One that they just launched a few years ago. But yeah, there is a satellite graveyard in the South Pacific Ocean, and that's where they try to aim to put because there's no islands around it. It's a very sparse location. Right. That's where they're going to place the ISS too when it's done.
Hopefully not take out New York City.
Yeah.
Or Moscow.
But even when they plan on bringing down like 5 pounds of this thing, the other 10 or 15 pounds are going to try to burn up in the atmosphere, but there's no guarantee that they will, and it'll be basically ripped apart. It doesn't just come through and burn up. Pieces of it start flying off first, and then what's left is a shell, and that shell is what heats up and burns up on its way through. So there are still could be thousands of particles that are still, even paint flakes or anything else that come off the spacecraft long before it ever enters the atmosphere again. So that's a danger for sure. So we should make a plan.
We also talked about earlier the physical size. I mean, not to be alarmed, not everything up there is huge.
No.
Not everything up there is one square cube. Mike was saying that some of the things are, smaller than a quarter inch.
Yeah.
And many of the things are the size of a softball, but there are things that are even larger again and smaller again. So there's quite a mixture of the physical size that these things are. But and then I think the graveyard was 15,000 kilometers?
22,000 miles up.
Miles.
Yeah.
So it's really not in any danger to hurt anything. That stuff that's way up there.
Yeah.
But the stuff that's floating around amongst the things that are alive, like the satellites, the ISS, things entering and coming back in to the Earth's atmosphere.
Yeah.
Well, anyway, but it wouldn't take much because, to make all this stuff light to send it up in the sky, they got to make it really light and thin. So
Right.
it wouldn't take very much for something to go right through anything we send up there.
And we,
Well,
we
Well, that's
send,
one thing they were saying. Even a paint flake, 1 centimeter square, doing 27,000 miles an hour, it's faster than a bullet.
Yeah.
8 kilometers a second. So if you got something that's going straight up, I mean, we don't launch stuff straight up. Our idea is really to get it, horizontal as quickly as possible,
Yeah.
right? But even at that, if you've got other particles coming in from the side at 8 kilometers per second, that can punch a hole right through
Yeah.
just about anything, right? Anything it's a good size, like a
Yeah.
softball size.
Crazy.
Yeah.
So yeah, it's scary for the future astronauts who are going to be going up. They've had to. Is it 3 times now that the astronauts have had to take shelter inside the Russian module?
Yeah.
Because of the debris.
Because of the debris, because they weren't
Yeah.
sure what was coming by, so they had to take that protection just in case. But when we're putting the astronauts in danger for that type of thing with space debris, I mean, we all see it passing through our, we see satellites all the time passing through our eyepiece when we're looking at them. And again, with astrophotography, you can remove most of it, but it's more of a danger, I guess, for those future astronauts who are going to be up there, and for any satellites that are placed up there.
Yeah.
They have to understand what orbit it's going to be in, and is there anything
Right.
else in that orbit that's going to cause an issue, right? So, I mean, to have a full crew of people watching 27,000 objects, 24 hours a day, it has to be there has to be a reason for all that happening. Like, why are we doing this, right? Why are we making it worse?
I assume a lot of that stuff to do with projections of when they are going to be launching. Is there like that chart that Mike showed? Like, is there a specific pocket where there's a whole lot more of that than maybe in another area where there's just a little tiny bit of it? And are they aware of those, areas? And I'm just wondering, do they consider those things?
Create like a no-fly zone for satellites or something.
Well, that's the thing. It's not regulated. Space is not regulated, so they can put up anything they want, right?
Yeah.
The only thing that they have to get in, I believe, in the U.S. is a FCC regulation so that they can operate at a certain frequency. It's not the simple fact of the actual rocket or satellite that's going up, but it's more the fact of what frequency they're going to operate on when they're up there. So, so there really is no regulated area in space that they can say, okay, before you put that satellite, we need a plan to say we're going to bring it down at X time, and how are you going to bring it down? Right?
Yeah.
So, we should be stopping it now.
Brad Parrish said all the debris, and it still doesn't compare to the number of mosquitoes out here right now.
Yeah.
Yeah, but we can fix that. True enough, Brad. Claire's on here. Claire says, hi all, lots of red alerts for Aurora in recent days here in Scotland. Too late to see it right now, really, unfortunately. I've been watching that as well, Claire. There is a number of reports of Aurora. Actually, it was KP4, I believe, yesterday. Of course, in our area with cloudy skies, we never get a chance to see anything anyway. But if there's one spot that's cloudy on the planet, it's going to be here. But anyway, yeah, we should be watching it over the next number of days, especially with those big, huge sunspots that are coming out. And I got a few photos to show about that later on, so we'll talk about that a bit later. Jeff is asking, what was that website again, Mike, please? Or you can put it there. Perfect. Okay, thank you.
Yeah.
All right. Okay, we're all set. So that's our talk on space debris, and we're all concerned about it, of course, and the less the better in this case, of course. But let's hope that this new program with ESA, this new experiment that they're going to try, is going to work out. And it's a 75 million euro project now. I guess $75 million to bring down one satellite seems pretty costly, but I don't know what they cost to put up. So maybe they'll come up with other ideas along the way too. So let's just hope, fingers crossed, that we'll be able to clean up that environment above us. Let's not leave our junk everywhere we go, like on the moon and everywhere else, right?
Mm-hmm.
Okay. Let's go from there then to how about the Mike Guyver next?
Okay.
Mike
Should
Guyver.
be coming up here. All right. Mike Guyver's tip of the week this week is: how do you keep dust off your telescope optical train after you remove your telescope dust cap? Now, I know Paul was a little confused what I meant here, but every telescope comes with a dust cap. When you set up your telescope for observing, you have to remove it to put on your dew shield or solar filter or something like that. If you're not using it for a while, but you want to keep the dust off the objective or solar filter without having to remove the stuff you just put on, How do you do that? Well, here's how you do that. With a dollar store shower cap. And you guys have seen this, okay? They're fantastic. They come in various sizes and not only fit on my great big noggin, which will be like a 12-inch dub, but they come every color of the rainbow. They fit perfectly with an elastic band around the edge of your objective. You don't have to take your solar filter off. You don't even have to take off your dew shield. It will fit right over the end of your dew shield. Leave your dew shield or solar filter in place, as you see here. Stretch the shower cap over the filter at the end over the end of the dew shield. The elastic band will hold it in place, even in the wind. And then when you're ready to observe, you just remove it. And personally, I like the polka dot ones.
You do. That's true.
Your problem is solved. And there I am at Fundy National Park with my shower cap. Okay. And once again, you might laugh at this MacGyver tip, but guess what? It works.
It does. And it's like one of those things that when you're driving through some place, like, look at that.
Yeah, exactly.
Yeah.
You'll never look at shower caps in the dollar store the same. Trust me on that one. That's my MacGyver tip of the week.
Awesome.
So,
That's a good one. Good cheap one.
Well, I love seeing Little Lotta. Every time I go up there, there's Little Lotta's polka dot dress.
Yeah.
gotta have my polka dots.
The thing about the MacGyver ones is that they keep your costs down so you can spend your money on other stuff that you really want to buy. Right? That's the idea. All right. Thanks, Mike.
Or a quick fix.
Or a quick fix. That's it. Yeah. Like a dew shield. Okay, let's go with an astro tip of the week, Paul. What do you got there?
Alrighty. Let me just get that ready here. Where did it go? It always disappears when I want to use it, right?
Mm-hmm.
I'm like you. I've got a bunch of screens going, which is just bear with me for a second. I'll find it.
Jamie says I have 2 polka dot ones. There you go, Mike.
Perfect.
There it is. Okay. So my astro photography tip of the week is going to be on what everybody seems to be taking pictures of these days, and that's the sun. So I thought, well, we might as well just spread a little information on about what we need to do and what we're actually looking to buy if we've never done it before. And so solar imaging tools, what to get and what do they do? So filters. So there are 2 main kinds of filters for solar observing or solar imaging, and they are either white light or hydrogen alpha. And my topic today is going to be on the white light filters because that's the most affordable and that's the one that most people start with. So with different filter types, let me just see if I can make that a little bit bigger here. There we go. So there's different filter types that are out there. The most common that we see are the Bader solar film type of white light filter. And they come in a variety of different styles so that you can affix them to the different type of telescopes that you have. And there are also the glass ones. Now the glass ones, albeit a little bit more solid and rigid, don't tend to give us as clear a picture, and they tend to put a yellow skew on or yellow cast on just about everything. So you can buy them prefixed, or you can buy the Bader paper and make it yourself. So these are the different types of configurations that you might see out there. So again, this is a typical telescope that a lot of people have. And the way to fix their solar filter to the scope would be to have it fit the scope, first of all, but then put on the safety Velcro straps so that it stays in place, so that it doesn't blow off in the wind and you lose your sight. For the same type of telescope, there are another way to put it on, whereas if you look at the little screw in there, those 3 tiny small screws, well, they actually drop down into the telescope and they touch on the ring that goes around your corrector plate. And then there's 3 larger screws on the outside that you adjust to fit the size of your telescope, because they have a small variety of sizes of scopes they can fit. So that's how that would fit on. If you're using a refractor, then you would use one that would be that you could just slide and pop right over the front, or you can get them that are similar to this style. If you're going to do a paper one and make one your own, when you buy the paper, they'll give you instructions on how to actually build one for your telescope. And if you follow the instructions correctly, they are a very, very good thing to use. They work extremely well. So white light wavelength. What is it? People saying, well, what bandwidth does a white light filter cover? Well, what a white light filter covers is everything. So it covers the full spectrum of visible light, and it blocks all wavelengths equally. And so what it does, it reduces the sun's energy to a safe level. So that's really the job of a white light filter. And so again, that would be what they call a full spectrum filter as opposed to a narrow band filter, which would be the hydrogen alpha. So imaging or observing. So if you're observing film must be a neutral density value of 5. If you're imaging, the film will be a neutral density value of 3.8. Now, this is important. You can use observing film for observation and imaging. You cannot use imaging film for observation. So when you're buying your paper, look at those neutral density values, make sure you get at least a 5, which I think is about what you're going to get anyway for most observing paper. So what can you see with a white light filter? So you can observe features across the photosphere, which is the area of the sun that the white light filter focuses on, such as sunspots, facula, and granules. So those are the 3 main things you'll see. So here's an example. So sunspots, of course, are those things that we see, those dark spots on the sun. And in a sunspot, there are 2 main features, which is called the umbra, which is the dark spot in the sunspot, and the penumbra, which is the sort of lighter tannish color outside, 2 different heat temperatures. And of course, this is where the black spot is where some of that energy would be ejected from. You can see the facula, which is this white looking stuff that you see, and you'll see it a lot right around sunspots, not in this particular image. If you get close, you could. And so that's one of the things you can see. And of course, granules, which are the really small looking, the pimply things, let's call it, looking like an orange surface on there. So when you're photographing, try to get all of these things into focus. Now, to be able to see the granules, you're probably going to have at least a 6-inch or an 8-inch SCT to get in that deep, unless you can really crop your sensor with a high, with a lot of megapixels. Then you can bring it up and you still have good resolution when you blow it up. So what will it look like? So if you're shooting with a white light filter, it will look very much like a cue ball when you're going to play pool with a bunch of black stuff on it. That's typically what you're going to see when you use a white light filter. And what it should look like after you apply false color to it, it will look like this. And I showed the false color, I think, a couple of weeks ago as to how to do that in Photoshop. It's quite simple. So this was done in 2021. This was when the sun was just starting to become active again, that kind of a thing. So so that's pretty much it on white light filters. So the tip of the week is choose the right filter for the right job, choose the right filter for the right telescope, and be safe and have fun with all of your sun images.
Awesome. Thanks, Paul. Great tips. Always nice to enjoy the sun, especially now because we're right into the, we're ramping up to solar max. We're not there yet, but not till 2025. So we've still got a couple of years, 3 years yet before we get to maximum.
Yeah.
And look at the sunspots
Well, it's picking
now.
up fast.
No, just 8 or 10 of them up there now, like just crazy. And some of them are 7 or 8 times the size of the Earth. So we've got a busy season or a busy couple of years coming up. So the thing about astronomy is that it's not all nighttime viewing. Daytime is great for viewing as well. So you got a moon up sometimes in daytime, and you've got the sun up. So it's a great thing to learn. Okay, from there maybe we'll go to our What's Up talk.
What's up, Doc?
What's up, Doc? Yeah, what's up, Doc? First of all, I got to say hello to my brother Danny out there who watches us faithfully every week. So hello, Dan.
Hey, Dan.
To make sure we say hi to Dan. Okay, let's get up our What's Up this week talk. Share my screen here first of all. Somebody's popcorn's ready.
Fries are done.
Fries are done, yeah.
Fries are done.
Okay. Okay, so what's up this week? Let's take a look here. I'll go from the beginning. That's a good spot to start. Yeah, I guess. Hey, did you know that the moon is about 400 times smaller than the sun, but also just happens to be 400 times closer? So the result is that from Earth, they appear to be the same size. And I keep bringing this stuff up because we're heading to a solar eclipse. That clear day, the one clear day we're going to get in 2024.
Yeah.
Oh, if only.
We'll wait and see. Okay, anyway, let's go on to what's coming up. So we've still got our planet show. That's still the best part of the show right now. Best part of the planets, I guess, is in the morning sky. So Tuesday, the moon greets Jupiter and Mars. On Tuesday morning, look to the southeast to find our waning crescent moon nearing Jupiter and Mars from our point of view. Look at the time of day, though. 4:30 a.m.
Wow.
To catch them, because we're getting an awful lot closer to our summer solstice now, which is, of course, the longest light day of the year. So we're out there pretty early. Wednesday, you get another nice occasion, though. Here's the moon, Jupiter, and Mars. They form a really nice celestial triangle. So that's one to watch. And also on these dates, too, if you happen to have a telescope out, don't forget to take a look at Jupiter and some of its moons, because you'll always get at least a couple of moons beside it. And these two are getting closer together. We're going to talk about that in a second, too. On Friday, the moon greets Venus. Dazzling Venus, the second and the third brightest objects in our sky together again. So some nice morning shows there if you get up nice and early. 4:45 for that one. That's not too bad. On Sunday, coming up, the conjunction of Jupiter and Mars. So next Sunday, look to the southeast very early in the morning for a conjunction of Jupiter and Mars. The two planets will appear less than the width of the, or actually appear 0.6 of a degree apart from our point of view. So the moon is actually half a degree, so it's roughly half a degree apart. Somebody baking a cake there or something?
Yeah.
Okay.
I think the team wants to say it's done.
Okay. So let's take a look at how it's going to look now through binoculars. Here we are, the view through 10 by 50 binoculars. So this is on the 28th on Saturday. And then we can see the view again on Sunday. This is the conjunction when they're at their closest. And here's our view on Monday. So we can see how they've switched positions there. Jupiter's getting higher, Mars is a little bit lower, and Jupiter will continue to get higher over the next little while. So we've got an opportunity over a few days. This is the view through 10 by 50 binos. So you should be able to catch them both easily in a set of binoculars, and also a few moons, as I mentioned. So, ding. Anyway, evening sky though. Here we are, a sure sign that we're heading towards summer, though, is the return of the summer triangle. That's an asterism that's comprised of the primary stars Vega, Deneb, and Altair in the constellations of Lyra, Cygnus, and Aquila.
Yay!
And Paul is especially happy to see Cygnus once again.
Oh, yeah.
Oh, yeah. That forms the summer triangle. So there's lots of targets in that area to check out for sure. Here we are with Lyra and the Ring Nebula and lots of stuff in Cygnus. And anyway, we know that our summer sky is coming for sure, and that also means that the spring constellations are heading farther west. So although they are still in perfect viewing position, there's no doubt that the spring constellations are moving on soon. But this week is a perfect time to enjoy them, especially under the belly of Leo and within the realm of the galaxies, the area that we call, which is the Virgo supercluster, I guess. So we're right in this area here of the sky. This next week makes the observing a little easier since the bright moon is up very late now as it heads towards new phase. So this is the time to be out looking for those faint fuzzies, those deep sky objects that we all enjoy so much. You can always go to sjastronomy.ca, there's where we present our calendar for the month of May and June in this case. And here are the events that I mentioned through next week. We also have our RASC NB meeting next Saturday afternoon. So you can go to sjastronomy.ca where you'll find that link right on the right-hand side. You can download the calendar right from there. And we also like to mention Lisa's Look Up, Astronomy and More. Lisa puts out this wonderful chart every month. This is the May chart. She's probably getting ready for her June one soon, I assume. But anyway, she lists all the events that are coming up in May in that particular month, then the peak times of when to see them, and what to use to see them with, naked eye, binoculars, or a telescope. So you can find Lisa's Look Up Astronomy and More at Ruby Moonbeams on Instagram, Facebook, and Twitter. And that's what I get to say about that there. So that's the things to look at this week in the sky.
Ta-da.
Ta-da.
All right.
And let me take a look here. If I still get it open, I don't know if I do. I wanted to open up something else here. Maybe I don't have it open. Just quickly, we'll take a peek at this. Just bear with me for a second. It's just opening up. Talk amongst yourselves there.
Where's that popcorn that was been
There,
dinging?
yeah.
Ding. Yeah.
Okay. Let me bring this down here. And you guys know this program anyway, Stellarium. So I just wanted to take a quick peek here at, I'm going to take the time ahead to tonight a little bit later. We'll save that time, and we're going to wheel around here to take a look at a couple of constellations. So let's go here and here. There's the bright star spike up. And we zoom out a little bit. We'll find Leo right there. So there's Leo and Virgo. And if we bring on our deep sky objects, we're going to pan in this area. So here's the area of sky between Leo and Virgo. And watch as I pan in. And all these little orange red circles here are galaxies. So let's go in a little farther. And we'll get rid of this here just to, so you can see how this stuff presents itself. There's so much.
That's space junk?
That's space. That's another kind. That's the space junk we like to see. We like this stuff. There's the Virgo cluster. There's M87. Markarian's chain. So there's a whole lot of stuff in this area to observe. Right, Paul?
Oh, yeah, there is. I've been there this year, by the way.
Now, saying that, if you turned on satellites, you'd see the space junk going in front of that.
Probably, yeah. There's that nice chain of galaxies called Markarian's chain. So
Yes.
beautiful through telescope and beautiful if you want to image it. There's M87, which is the largest galaxy in our particular part of the sky. 100 trillion stars, apparently.
It's the black hole. First time is in the black hole.
Yeah, that's
too.
right. That's the first time we imaged the black hole. That's right.
There goes the satellite.
There goes the satellite. Here we go. See? Yeah. There's another one
And
going
they're
that
going
way.
to
Whoa.
Oh, they were
We
close.
There
do
it
know.
We see a lot of those, don't we? Yep. So anyway, that's the area of sky in between Leo and Virgo. So if you just get up with a telescope and pan and around that area, you're going to catch a couple at least in your field of view. Even with binoculars, when you get down to the Leo, the Leo triplet, that kind of thing down here. There's a couple more coming by. You're going to catch a lot of beautiful stuff. So these dark evenings that we're into now, where the moon is coming up quite late, and as we work our way towards new moon, that's also going to be a time when we can get out here and see this stuff without all that light pollution caused by the bright moon. Okay, let's go from the what's up then to a Bino Bud. And Robert says the policy that is called, it's called the Maritime Weather Anti-Astronomical Event Policy. Anti-astronomical event.
We
That's
signed
true.
up for that, didn't we?
Yeah, we did, unfortunately. Okay, the Bino Bud.
So true. All righty. Binocular target of the week. This week, my Bino Bud is the Seven Sisters of the Pole. Now, there's a riddle that goes with this, and you guys heard it before, but see how good your memory is. The seven sisters went to the cottage, and every single one of them decided to start doing something. The first one started reading a novel. The second one started frying pancakes. The third started playing chess. The fourth started doing crosswords. The fifth started doing laundry. And the sixth started watering plants. What did the seventh sister do? And I'll tell you when we finish.
Okay.
So the Seven Sisters of the Pole. Very much a binocular asterism, the Seven Sisters of the Pole are a group of brightest stars in the shape reminiscent of the Pleiades. Although the pattern is similar, these sisters are larger than the original. Very close by is the open cluster NGC 188. How do I find it in the sky? If you go out when it's dark now, 2300, Look due north and you'll see Polaris. Come down just a wee bit, and the Seven Sisters of the Pole are right in here. Again, a little closer look. There's Polaris. There's the Seven Sisters of the Pole. It kind of looks like a Pleiades, a miniature Pleiades.
It does. Wow.
Yep, it does. Yep.
What will you see? This is basically what you see. Look at that. Get just a different version of it. And in 10 by 50 binoculars, look, there's Polaris. It's a good sized target. It takes up, more than half your field of view, which when you look at the Pleiades, it does the same thing. So that's why they call it the Seven Sisters of the Pole, the 7 bright stars there. Compared to the full moon, well, again, the full moon will sit inside just the center portion of it, not including the pieces that come down here to the side. So there you go. And what we all see when we get our first telescope.
Yeah. Of course we do.
How true, eh? How true.
Yes, sir.
Now, before I finish, the answer to the question, what the seventh sister was doing, figure it out. She was playing chess because it takes 2 people to play chess.
Mike
There you
Thorne got that.
He did. Yep.
Excellent.
Like Thorn
Good
together.
for you, Mike. And that's Binocular Target of the Week by Bino Bud.
Yeah.
Hey, good one. Thanks, Mike.
Oh, I wasn't aware of that. That is pretty cool.
I did not know that.
Yeah. Seven
No.
Sisters of the Pole Dancer, or pole.
Family show.
Yes.
Reminder. Okay. Let's go from there to how about a Rosanna's fun fact? We'd like to have one of
Yeah.
those this week.
All right. You just hang on. I'll get that up. Just take me 1 cent on.
And then we'll have our photos and close out the show after that.
Yeah. Not be that there. All right. So I got that done. Let me just shrink that. And then I got to open this. Yeah. Come on. There it is. Whoop, there it is. All right. So let me just share my screen. And we are getting ready for
Rosanna's Fun Fact.
I just lost all the notes on Rosanna's fun facts. It's just like,
Uh-oh. And that was another.
I tell you, I'm telling you. So anyway, in this week, Rosanna says, hi, Paul. History is a funny thing, and it keeps changing depending on how thorough the author is or how a particular government wishes the story to be presented to the people. And here we go. So in school, I was told that the Russian Sputnik satellite was the first man-made satellite object in space, and you will still find it written thus in many books or articles. Now watch, okay, so we had a video there, and I wasn't prepared to put the video up. And also find in some museums dedicated to spaceflight. However, according to Matt Brown, editor at large, who has a background in science and a penchant for history, there is a wonderful and persistent urban myth that the first item to cross the space boundary was a manhole cover. So what? The metal plate was a 1-ton cap placed above a nuclear test chamber in Nevada in August 1957. When the bomb detonated, the cap was propelled over the hills and far away, very far away. The speed was not recorded, although there are varying sources that state it was 41 miles per second, way above what one needs to escape Earth's gravity and enter into space. But any object traveling such speeds is likely to burn up before reaching space. Even if the manhole did somehow reach space, which is greatly doubted, it still wasn't actually the first man-made object to do so. Unfortunately, the distinction of creating the first object was to reach space belongs to the V-2 rockets launched by the Nazis in 1940. The V-2 rocket ready for launching at Cuxhaven in Lower Saxony in 1945 is the image that you're looking at. Now, the V2 achieved a height of more than 109 miles before crashing back to Earth. So the actual first human object into space was launched from German soil 13 years before Sputnik, but still it carried a payload of evil and also did not go into orbit. It tends to be ignored in the more heroic narratives of space exploration. And there is even a photo of Earth from space that predates Sputnik. Both the USA and Soviet Union built on a captured V2 technology and launched their own space programs. One US launch on October the 24th, 1946 included a camera. The images were snapped at 105 kilometers above the Earth's surface. So there's the first photo from Earth, from space. And there it is. The rocket fell back to Earth and smashed to pieces, but the film survived in its steel casing. Sputnik was the first human artifact to orbit the planet, and that is a whole different kettle of fish. Matt Brown admits it might be nitpicking to focus on the wording of the achievement, but it does matter to some people. So just how far is it to the official space boundary? It isn't as far as you might think. The internationally agreed boundary is easy to remember at 100 kilometers. This isn't an arbitrary designation. At the height, the atmosphere is so tenuous that a winged aircraft could not possibly operate. A little beneath it, and you could theoretically pilot an aircraft if it were going at colossal speed with specialist aerodynamics. A little above, and the speed required to lift would be so great that you would find yourself orbiting instead. The boundary is known as the Kármán and the Kármán line, and after Theodor von Kármán, the Hungarian-American engineer who first calculated the limit. It is the internationally agreed upon boundary of space as set by the Fédération Aérotechnique Internationale, the entity which keeps an eye on aeronautical and astronautical achievements. Well, it's almost internationally agreed upon. The U.S. Air Force decided to have its own definition, and it considers 80 kilometers to be the boundary. This is where the mesosphere meets the thermosphere. Many more American test pilots can claim astronauts' wings this way. Did you know that I've been an astronaut for at least 6 years? And that's a little like getting a copy of the exam before exam day. The rest of the world observes the Kármán line, but boundaries are personal issues for many. Okay, everybody, let's talk about boundaries. And that is this week's. Come on.
This is week's. There it is.
Rosanna's Fun Fact.
Yay! Awesome.
That's awesome.
Yeah.
That was awesome.
Did somebody tell her what we were going to talk about this week? Because that's just timely, like perfect time.
She is like the most timely person and has the most intuitive senses as to what is going on.
Yep.
That's crazy.
So
1946. Anyway. Imagine that picture taken like that, though. That's proves the flat earthers wrong back then. That far back.
Anyway, thank you, Rosanna. That was
Yes,
an
thank you, Rosanna.
awesome fun fact.
Awesome.
So
Thank
cool.
you very much. Once again, amazing.
So cool.
Okay, let's get to some photos then. We've got a few here to share. Just give me a second to get my notes up as well. There we go. Okay, let's share my screen first of all. And we're going to go with this one again. And full screen. Okay, we've got a couple here. First of all, from Lisa Fanning. She says, "Hi, Chris. Despite the forecast, Rob and I dragged our chairs and cups of tea outside and played Dodge the Clouds on Sunday. We were able to catch a glimpse of the first half of the eclipse to totality until a solid wall of clouds and the rain came. Well, we had that earlier, so you did very well."
Well, it's nice to see it because nobody saw it here.
That's it, yeah. Photos were taken from 10 p.m. Eastern Time to 11:33 p.m. Eastern Time near New Jersey, with a Canon PowerShot SX70HS and assembled in Bazart for iOS. The second photo shows the moon a minute before totality. Excuse me. Here to better conditions in November for sure. Yeah, good shot though. Great captures, Lisa.
Yeah.
Well done. Good
Very
to see
well.
somebody got it.
Excellent.
We got a couple here from David Samard of the Sun this week. Look at the size of that guy.
Yeah.
Isn't that
Yeah,
nuts?
I don't think he was paying attention to Mike on his cleaning the optics.
Yeah, you might be right. There's another one. That's a huge sunspot. Now it's moved over a little bit this way, but right now it's got it has the ability to be able to produce X-class solar flares at about 10% apparently right now. So that one you can actually see at sunset. If you were able to watch the sun at sunset, when it gets down into that real thick part, you'd be able to see this big spot sitting out there. It's huge. About 7 times the size of the Earth, I guess. So, well done, David. Thank you for those.
Yep.
Next up, we got these from Brad Perry. He says, "Hi, Chris. I have a couple of photos to share this week. I was in St. Andrews. Look at this, from St. Andrews on Friday.
Oh,
Friday
nice.
night to play some music, and decided to take advantage of the fact that I was right on the ocean, late at night, and with the fairly clear skies. Now, the first photo is of the Milky Way taken at around 1:30 a.m. Beautiful from St. Andrews. Good stuff.
Oh, nice picture.
Yeah. Look at the detail. Nice, eh?
Yeah.
Beautiful.
And this one, you see the second photo is a composite of the moonrise made up of about 75 photos taken at 15-second intervals between 2:11 and 2:29 a.m. What a cool shot.
That
It
is
a very
cool.
cool shot. It's awesome.
At the end of the sequence, one longer exposure was taken as a base image, and then all of it was combined in Photoshop. I think it's neat that it clearly shows the way the color of the moon changes as it rises. It sure does. What a great
Sure
shot.
does, yeah.
It's fantastic.
Well done. Well done.
Awesome.
Great shot. Good innovation there. Good imagination.
But it's I really, really like what and until he mentioned that the way that the moon changes color, it just looked like a cool picture. But
Yeah.
now it's even more cool.
Yeah.
Oh, yeah.
Yeah, it is.
Yeah. That's
Look at
awesome.
that line where you can really see a definitive line where
Yeah.
it goes from dark orange out of the atmosphere up and start clearing.
Yeah. Crazy.
Yeah. Amazing.
That's fantastic.
Nice
Well
shot.
done. Well done.
That's
I love the
so
reflection too. Like,
Yeah. Yeah, great shot.
awesome.
Okay, from there, Kathy Adams has a nice photo of the sun from May 18th through 30.
Yes, sir.
Sunspot 3014 is really growing. She said that's the one there that we were talking about. But look at the sunspots. 1, 2, 3, 4, 5, 6, 7 groupings of sunspots. Crazy.
pretty crazy.
Very nice. We got this one from Stefan Picard. Stefan says, "Hi Chris, out Friday night with such a beautiful clear night. I took 60 frames at 20 seconds, each with 75mm lens and camera settings at ISO 3200 f4.0. Stacked in Deep Sky Stacker and processed in both Photoshop and Lightroom. Cropped about 50% in order to take the treetops out. So I love this part of the sky, Antares and M4 crab cluster. At the
It's a
bottom,
busy part of the sky.
yeah, all the way up to the Oaf Nebula.
Yeah.
Very nice.
Very nice.
Busy part of the
Busy,
sky.
busy. Yep. Awesome. Thanks for that, Stefan. Robert Gadet, some sunspots. May the 20th. Spot 3014 is now 7 times the size of the Earth.
Looks like a lobster.
Yeah, it does.
We'll call it the lobster spot. That's a big spot, man.
I know a few people tuned on here saying, I don't remember sending him the photo. It doesn't matter. Once you put up a photo, it's fair game. So I go grab them. If I want them, I go grab them. So
Yeah.
Right on.
there we go.
Nice shot, though.
Nice shot. Very nice, Robert. Joey Croswell of the Sun here.
See, it looks like a lobster.
Yes, it does. 3014
Nice
again.
shot.
And another here.
Pretty nice.
Joey's
Yes,
just got a
sir.
brand new sun filter there, so he's trying it out, doing a great job with them,
Yep.
for sure.
Well, that sounds getting busy.
Yeah, it
There's
is.
there's that white light look we talked about.
And we still
Yes,
got a couple.
I-
They say
I-
you still got a couple of years to get through to the solar maximum. So we're going to have a lot of activity. This is a really
Oh,
active
okay.
cycle. I think it's much more active than what they expected. I think. And again there. Oh, this guy. Yeah, look at this.
Oh,
Sunrise on the river.
There you go.
That's an awesome shot, Paul. That's from Mr. Paul Owen.
That's so cool.
Yeah, it looks like the trees are on fire and there's smoke coming off them.
Yeah, really.
Yeah. What a great
That's
shot.
different.
Yeah.
It's
Nice
chilly a little bit, though, was it?
Huh?
Looks chilly a little bit.
No, it was actually quite nice. It was about 9 degrees,
Right on.
and that's heading up towards Bloomfield. And just because we always do that, we got your sun up first, and then come back the other way.
Yeah, that's gorgeous.
Yeah.
Yeah.
Well
Don't get better than that.
No.
Nope.
Great stuff, Paul.
Yeah. It was,
And well, we had to throw this one in. This is Mike's.
oh yeah,
Mike just had to capture it. M40. So.
is this the real M40?
Yes, it is.
So there's a Messier list of 110 Messier objects, and one of them is M40, and all M40 is these two stars.
That's it.
Yeah, so Mike said he had to capture it. I'm glad you did, Mike. That's one you can scratch off the list for sure.
Yeah.
The least photographed. The least photographed item, Messier.
There, a lot of people might miss that. See, so you would have the list done before everybody else.
Yes. And it's so hard to find.
Yeah. Pick two.
Yeah. Robert mentions that the large blow up of the
sun?
3014 was his.
Oh, it was.
Yeah.
Okay, sorry, Robert. Yes, I thought you had that. Oh well, okay. This one here, I may have mentioned it wrong.
The one
Was
just
it,
before Joey.
That one there.
Yeah,
Yes, that was Robert's. Yes. Sorry, Robert. Great shot.
Nice shot.
Okay, and if you'd like to send in your photos, we love getting them and we love sharing them, as you can see. So you can send them into either Sunday Night Astronomy Show at gmail.com or send them into SNAS, S-N-A-S, at astronomybythebay.ca. Both addresses are working. I checked them today, so we'd love to get your photos and we'd love to share them with everybody else. So please send them in.
Send them.
Send them in.
That,
Okay.
the compilation was just unbelievable.
Yeah, what a great job. Good
He
idea.
made- I don't know if he's watching, but if he is, he should send that into Sky News and explain the not just the composition, but what your scientific reasoning was behind it.
Yeah.
That's an amazing capture.
Absolutely, yeah. Brad, I think Brad is here on YouTube. He's watching this tonight, so
Yeah.
that's great.
All right.
Yeah.
Amazing work. Okay, so then in closing tonight, we'd like to thank all of you again for your continued support out there. We also like to thank Rosanna, of course, once again for another interesting fun fact segment. Always very timely.
Yeah.
Really enjoy them. Thank you, Rosanna. We also hope that those of you who have joined us from Rogers enjoyed the program here tonight. If you would like more information about the wonders of the night sky, you can find me at astronomybythebay.ca. And thank you to all of my YouTube and Facebook and Instagram channels out there who continue to share our broadcast with your family and friends, such as the NB Storm and Weather Center, our friend Sean out there, Trudy, of course, who shares it around to, 50 different pages, I think. she gets it out there quite a bit. And everybody else who's out there sharing it as well. We really do appreciate it. Remember, too, we do love getting your photos, so send them into snaz at astronomybythebay.ca or Sunday Night Astronomy Show at gmail.com, and we'd be happy to include them in our next broadcast.
Could I just?
Please.
Sorry.
Yeah, go ahead.
I was just going to interject. I just wanted to make mention that our first New Brunswick Star Party is not this weekend coming, but next at Quishabuquack, June 2nd and 3rd. So for those who have nothing to do and they want to come up and hang out and finally get us back together doing astronomy outside with people, it's going to happen at Quishabuquack National Park, June 2nd and 3rd.
Awesome. Thanks, Paul. Yeah. So just contact the park as far as you want to make. Once you make your camping reservations, everything else is free, like for our part of it. So,
Yeah.
So awesome. Can't wait to get back to the public again. Okay, we're also looking again for suggestions for topics for future shows, so you can send them into the same address, and we'd be happy to make it happen for you. And please let your friends and family know too that we are here every Sunday night at 8 p.m. on YouTube and Facebook to try to entertain you a little bit, educate you a bit on the astronomy and the wonders of the night sky. So for now then, from Mike and Paul and I, we wish you a safe and happy week, everybody. Lots and lots of clear skies, we hope. And as we like to say, open your eyes to view the skies and keep your scopes pointed up.
Yeah.
Good night, everyone.
desk.
Night, everybody.